Okay, on this question, it says an object weighing 180 pounds is suspended by two cables, each pointing 42 degrees away from straight up. Cables have equal tension T. So there's some kind of 100, you see the 180 pounds going straight down. There's some kind of object, that's hanging. Yeah, you could draw some if it helps you. Some kind of object, down here, and that's why this arrow's down. It's this object weighs 180 pounds. And it's pulling straight down. And they're holding up that object by one rope going this way and another rope going that way. And both these ropes have the same tension T. And that's what they want us to figure out. What is T? What is the tension in the cable? How tight are both those cables? It says they're equal tension. The cables have equal tension T. And they're both at a 42-degree angle holding up this 180-pound weight. Okay, so how do we do this? Well, whenever you have a vector, the way you always handle a vector, let's start this one with blue here. So a vector has always got an x and a y component, and it's whatever the force is times the cosine of the angle, comma, whatever the force is times the sine of the angle. That's the x and y components of any vector, meaning if this cable is pulling up to the right and this cable is pulling up to the left, when a cable pulls up to the right, that means it's pulling right and it's pulling up. It has an x component or part, an x part of it, and it has a y part of it. So that's what we always do with vectors in engineering and science, is we break vectors into their x part and their y part. So whenever a vector pulls diagonally, it's got a sideways part we call x and a vertical part we call y. So that cable pulling up to the right has an x part and a y part. How do we find those? The x is always the total force times the cosine of the angle, and the y is always the total force times the sine of the angle. Now, what angle? Well, that's what you got to be clear on. Vector angles must start at 0. What do we mean start at 0? Well, let me make this like a little axis system here. Here's 0 degrees, this is 90 straight up, and this is 180, and this is 270, the angles, right? So you have to start from 0. So when I say, I'm going to do this first one. This one's going to be, here's his angle. There's the first angle. Okay, and what's that angle? Well, if this part is 42, then this must be 90 minus 42, which is 48 degrees. That angle must be 48 degrees. From 0 up to our first vector must be 48 degrees. So I'm going to go T. So for the first vector, first cable, it's going to be T cosine 48 degrees, comma, T sine 48 degrees. And these little marks are just one of the ways we do vectors. Sometimes you can go I and J if you want. That's another way. It doesn't matter. However you want to do it. It's basically just the X and the Y, the I and the J, the first number, comma, second number, whatever. It's the sideways component and the vertical. Now, the sideways is always cosine. We know that. Cosine X has been cosine all semester long because cosine is adjacent. And sine has always been Y because Y is opposite. That's the Y, the up. And what's this T thing? Well, T is what I don't know. I don't know if this is 100 pounds, 50 pounds, 70 pounds. How many pounds, excuse me, of tension are in this cable pulling up to the right? Whatever that is, T times the cosine of the angle is the X component, and that same T times the sine of the angle is the Y component. Now for the second vector, let's go up to the second vector. So, okay, so the second vector is right here. And so should we say, well, he's 42 degrees? Nope, that's the mistake people make, is the angle has to be from 0. Vector angles must start at 0. So from 0 all the way to the second vector. So the second vector It's going to have an X and a Y. And this is going to be what? T again, because again, it's T, just like the other one was. Cosine. Now, what's the angle? Well, from here to here is 90, and then this is what? 42 more. So this is going to be 90 degrees plus 42 degrees, which equals 132 degrees. I read it right here. This one must be at 132 degrees. So this is 132 degrees. T sine 132 degrees. That's the part that usually tricks people. Are you tracking with me on that? Vector angles must start at 0. You can't just look here and go, he's a 42-degree angle. No, not from 0. He's 42 from 90, so 90 plus 42, right? This is 90, and then this is 42 more. So 90 plus 42 is 132. He's actually at 132, right? He's past 90, not quite to 180. He's at 132. So you got to use the correct angle. That's the second vector. Okay. And okay, what does that mean? Well, this is where you got to be real with this whole thing. What are they wanting this to do? They're saying, what is happening with this? Well, these two, this cable's pulling up to the right, this cable's pulling up to the left, and together they are equaling the downward force of 180 pounds. Now, what affects up and down? The Y component, huh? That means this, let me change the color here. This Y component plus this Y component, these must add up to equal 180 pounds. How do I know that? And you think you don't care about the X? I don't. I don't care about the X at all. I only care about this plus this must be 180. How do I know? Because this, oops, try it again. Because this vector, again, which is pulling up to the right, has a right component and an up component. This vector up to the left has a left component and an up. So they both have an up component. And those two up components must be overcoming the 180 down component. How do I know? Well, because it's hanging still, right? So the forces must be in balance. That making sense? Whatever tension is in this cable and tension in this cable, the upward, right? This cable again pulls up to the right, so it's right and up. This is up to the left, so it's left and up. This up and this up, which is here and here, must add up to be the 180 because they're holding up the 180-pound weight. So there's my equation. So T sine 48 degrees plus T sine 132 degrees equals 180. Right? I just added up this Y component and that Y component. They together must add up to equal 180 because the 180 is down. Right? The amount this is pulling up and this is pulling up must total 180 because we know this thing is pulling down at 180. It weighs 180 pounds. That big weight that's hanging there, that object weighs 180 pounds, which means it's pulling down 180 pounds. So how much this cable is pulling up and how much this cable is pulling up must add up to be 180 because they're holding that up. So then I have to solve this equation for T. How do you do that? Well, you want to factor out the T. Or you could just hit the buttons on your calculator, I guess. Yeah, I'm probably being too tricky. Let's just hit the buttons on the calculator. So I'm just going to figure out what sine 48 is here. I'm getting 0.7431. Use 4 digits, T. Plus, right, that was just sine of 48. And then the sine of 132, what's that? It's the same thing. 74331 T equals 1. I guess that makes sense. They're symmetric, so they're both pulling up the same amount. So if you add this and this on the calculator, you get I'm gonna do 1.486.4862 T equals 180. Then you can solve for T. Divide by 1.4862. 1.4862. Boom. Boom. T equals, and my calculator's telling me 121.1069, which is exactly what we got here. That's the answer. That's the tension in those cables. So again, whenever we have vectors, we always have to write our vectors as X and Y components, X and Y, sideways pieces and up and down pieces. And it's always the total tension or force in the rope or the whatever that's pulling there times the cosine of the angle. And that same for the X, and then that T times the sine of the angle. But you got to make sure you know the angle is from 0 to the vector, which that was easy, and then 0 all the way to that vector. And then we added up the two Y components to be 180 because we know this pulled down 180. You might think, what about the X? We don't care about the X at all. This object is pulling straight down. He's not pulling sideways. He's pulling straight down at 180 pounds, which means the upward pull of this cable and the upward pull of that cable must add up to be the 180. That's how they're holding it up. So this plus this, these guys add up to be 180. You can solve for the tension that must be in those, each cable must have 121 pounds of tension in it. Both of them having 121 pounds of tension, pulling up to hold up the 180. You might think, well, yeah, but 121 and 121 is more than 180. Well, it's because it's 121 in this direction. So it's only 90 pounds straight up and 90 pounds straight up, making 180 down. Some of it goes sideways. And so there we go.